Here we are going to solve a problem from Lilavati, a math text written 900 years ago by Bhaskaracharya or Bhaskara II. I have taken this from a translation made by Henry Thomas Colebrook in 1817. The statement is, in a pleasant, spacious and elegant edifice with 8 doors, constructed by a skillful architect as a palace for the lord of the land, tell me the permutations of apertures taken 1, 2, 3, etc. So we have a building, a palace with 8 doors, and we want to find out how many ways those doors can be kept open or closed. Clearly this is a combinatorics problem, and we'll be dealing with combinations rather than permutations, because the order in which the doors are opened or maybe entered or exited is of no consequence. But rather than taking that conventional approach, we'll be tackling it in a very different way. Maybe using binary numbers, we'll try to understand this process, and then we'll see a neat trick from Lilavati. Let us try a direct approach here. So we'll be actually taking these 8 doors and opening and shutting them one by one, and thereby creating some combinations. Let us see what understanding we gain from that. So we'll start this process. So all the 8 doors are closed to start with, and I'll start opening the first one, then I'll shut that and open the second one, then open the first one too, and like that I'll keep creating combinations. But quickly I realize that there are just too many of these, and there is all likelihood that I'll be missing some of these combinations, while even if some of those get repeated, I will not even notice them. So I need some way of ordering them, so that if I follow that order, I will not miss a single combination, and none of them will be repeated either. For that, I am going to take help of binary number system. See, these doors have only 2 states, 0 and 1, or open and shut. So I can code these different configurations in terms of zeros and ones, like this. For example, here all doors are closed, so each door is given the state 0, while if a door is open, I will say it is in state 1. And like that, we can keep generating these binary numbers successively, and thereby we can ensure that we will not miss even a single combination. But of course, binary numbers are not so easy to understand and their order. So we will convert them into decimal. So I'm going to take each of these binary digits, and I'm going to convert it or multiply it by its place value. So I'll multiply this with 1, then 2, 4, 8, 16, 32, 64, and 128. And when I add them up, I'm going to get a decimal number, which is easy to track. So now let us go on again and create these different combinations. And since we are having decimal numbers to track them, so we can always make sure that none of these states is missed or repeated. So if we keep doing that, then we are going to get numbers from 0 to, right now it is going up to 255. So in all, 256 configurations. But that is hardly surprising. We have 8 doors and each has 2 states. So the total number of combinations is going to be 2 into 2 into 2, 8 times, which is 2 raised to 8, or 256. So how does Bhaskaracharya solve it in Lilavati? The trick in Lilavati says that first you write numbers 1 to 8, because you have 8 doors, in a reverse manner. So like this, 8, 7, 6, 5, 4, 3, 2, and 1. And then just below them, write them in the ascending order, 1 to 8 again, like this. And then depending upon how many doors we are keeping open, we have to take ratios. For example, if you want to keep just one door open, take the ratio of one number from here and one number from the lower sequence, like this. So 8 upon 1. There are 8 ways of keeping a single door open out of 8. And what if you want 2 doors open? In that case, take 2 numbers from the top sequence and 2 numbers from the first 2 numbers from the bottom sequence, and take their ratio. So 8 into 7, 56 in the numerator, divided by 2, it gives us 28 combinations. Like that, we can do 3 doors, which will yield 56 combinations. Opening 4 doors is possible in 70 ways, while 5 doors can be kept open in 56 ways, and 6 doors have 28 combinations of opening them. And you will see this number of combinations start increasing, and then again they are tapering off, they are decreasing here. See, here we have 7 doors open, which amounts to 1 door shut. And how many ways you can shut one door out of 8? Of course, 8 ways. And finally, how many ways can we open all the 8 doors out of the 8 doors that are there? Of course, there is just one way. And if we add all these numbers, 8 plus 28 plus 56 plus 70, so on, we get the number 255. Then where is the last combination? The last combination is, of course, no doors are open, all are shut. So that is how we get 256. So that's the trick given, or that's the recipe given in Lilavati 900 years ago.